Hello everyone, I welcome you all. This is Lata, Avhad, working as an assistant professor in the Department of Chemistry at KVN9 Arts, Commerce and Science College, Nashik. In today's lecture, we are going to discuss about the biogenesis of alpha bisabolene, beta bisabolene, gamma bisabolene, bisabolene oxide A, bisabolene oxide B, and humulene from FPP. Now let us see the biogenesis of alpha bisabolene, beta bisabolene and gamma bisabolene from FPP. First of all, see the structure of FPP. Here OPP, here methyl group. This is the structure of EZ FPP. From this EZ FPP, here loss of OPP takes place and we get here a positive charge. This cation is called as farnesyl cation or EZ farnesyl cation. So in next step, this double bond attack on this carbon atom via this carbon and we get here double bond, here CH3, here positive charge, and this cation is called as bisabolene cation. From this bisabolene cation, on loss of protons, we get alpha sabolene, beta bisabolene and gamma bisabolene. So, I will write the structure of this bisabolene cation here. So, if you lose this proton, then we get this kind of moiety, and here double bond. This moiety is called as alpha bisabolene. If we lose this proton, here minus H plus, so we get this kind of moiety which is called as beta bisabolene. And if you lose this proton, here minus H plus, then we get here is double bond and this is called as gamma bisabolene. In this way, we prepare the alpha bisabolene, beta bisabolene and gamma bisabolene from the EZ FPP. Next, we will see the biogenesis of bisabolene oxide A and bisabolene oxide B from FPP. So, first structure of FPP. Here, use EZ FPP. Here, OEE. So, in first step, loss of OPP. So, on loss of OPP, we get here a positive charge, and this cation is called as farnesyl cation. So, in next step, this double bond attack on this carbocation and we get bisabolene carbocation. And here positive charge. This cation is called as bisabolene cation. In next step, on addition of water molecule, we get here OH. In next step, on enzymatic oxidation of this double bond, we get here epoxide. So in next step, this lone pair of oxygen attack on this carbon atom and there is opening of epoxide. So here epoxide opening and we get this moiety is called as bisabolene oxide D, and the opening of epoxide takes place on this carbon atom, that is lone pair of oxygen attack on this carbon atom and opening takes place on this side. Then we get 6-member ring. Here OH, here 2 methyl groups and here remaining moiety. Here CH3 and this moiety is called as bisabolene oxide A. In this way, we can prepare bisabolene oxide A and bisabolene oxide B from FPP. Next, we will see the biogenesis of humulene from FPP. First, structure of FPP. Here is OPP. From FPP, in first step, loss of OPP take place and we get this cation, and this cation is called as farnesyl cation. In next step, this double bond attack on this carbocation and we get here double bond, here positive charge, here double bond, here CH3, here another CH2 and here this bond is bonded to this carbon atom. That means the attack takes place by this carbon atom and we get this cation, and this cation is called as humulene cation. And so in next step, on loss of this proton, that is minus H plus take place and we get here double bond, here CH3, here CH2 and B4 attached to this carbon atom and this is called as humulene. So in this way we can prepare humulene from the FPP.